In section G2, we are going to evaluate functions for an expression. So instead of f of 3, we might have f of x plus 3. So instead of replacing x with 3, we'll replace x with x plus 3 on both sides of the equation. Very similar process. So in A, we have f of x equals 2x minus 3. So we're asked to find f of n plus 5. Since I replaced the x with n plus 5 on the left side of the equation, I'm just going to replace the x with n plus 5 on the right side of the equation. And we'll simplify that. That's 2n plus 10 minus 3. And so f of n plus 5 is 2n plus 7 when we combine like terms. Don't go any farther than that. The f of n plus 5 doesn't mean multiplication. It just means when n plus 5 is input, the output is 2n plus 7. In B, we have g of x equals 3x plus 5 over x minus 4. So if I want to find the value of g of 7k, I'm simply going to replace the x on both sides of the equation with 7k. Color coding it can help. Now we just need to simplify the right side of the equation. So g of 7k is equal to 21k plus 5 over 7k minus 4, and we're done. There's no simplification that can be done with factoring the numerator and the denominator. All right, let's keep going. So next step, we have h of x is equal to x squared plus 2x, and we are looking for h of x plus 3. So that means that we're going to replace the x with x plus 3. So let's go ahead and fill in those parentheses with x plus 3's. And on the right side, we have some simplification to do. Just think of it in order of operations. X plus 3 needs to be squared first. Now remember, that's x plus 3 times itself. So that's x squared plus 6x plus 9. You can't just distribute the square. Plus 2 times x plus 3. Now 2 can be distributed. Multiplication by 2 can be distributed to x plus 3, or multiplication can be distributed to addition. So that just gives us 2x plus 6. And now we just need to simplify by combining like terms. X squared plus 8x plus 15 is the value of h of x plus 3. Last one. P of x is equal to 6, the square root of 6x. And we are to find p of 2a to the 5th power. So that's going to be the square root of 6 times 2a to the 5th power. Let's simplify on our right side. That's the square root of 12 times a to the 5th power. We're looking for perfect square factors if we want to simplify that. So the square root of 4 is a perfect square factor, a to the 4th is a perfect square factor, and then that leaves us with an extra factor of 3 times a. So p of 2a to the 5th power is 2, because 2 times 2 is equal to 4, times a squared, since a squared times a squared is equal to a to the 4th, times the square root of 3a in simplified form. All right, your turn to try a below on your own. Okay, you should have gotten f of c minus 3 is equal to 5c minus 14. Now try b. Here's the result. G of x to the 7th power equals x to the 14th plus 3 times x to the 7th. Remember that you cannot combine those two terms together since they are unlike terms having variables with different exponents, variable factors with different exponents. All right, your turn to try c. There you go. H of c minus 1 is equal to c squared minus 7c plus 6. Things to be careful. c minus 1 squared is c minus 1 times c minus 1. So make sure that you're either foiling that or using a box to multiply. And when you distribute your negative 5, multiplication by negative 5 into the c minus 1, make sure that you distribute it to both terms. So that last term is plus 5. All right, last one, try D. So P of 3m plus 5 is equal to 6m plus 11 over 3m plus 1. Remember, that cannot reduce either. I know 6 and 3 share a common factor, but 11 and 1 do not share that same common factor. So all terms do not have that common factor. You can only cancel common factors if you can factor out from the entire numerator and the entire denominator. That's it for that section.